Welcome to the Microsoft Azure Fundamentals course, exam code AZ-900. This course provides essential knowledge of cloud services and how Microsoft Azure delivers them. We begin with an overview of cloud concepts and the benefits of cloud adoption. Next, we cover Azure architecture, including its global infrastructure and key components. You will learn about Azure Compute, networking, and storage services, and how they support modern workloads. The course also introduces identity, access, and security features within Azure. We will explore management and governance capabilities, including compliance tools and deployment methods. Cost management and pricing models are explained to help you understand financial aspects of the cloud. Finally, we examine monitoring tools that ensure performance, reliability, and accountability. By the end of this course, you will have a solid foundation in Azure fundamentals, preparing you for the AZ-900 certification exam. Before we get into the course, a quick reminder, please subscribe to our channel. Subscribing ensures you never miss a lesson and supports us in creating more structured, exam-focused training. Your support is what makes this possible, and it motivates us to keep producing valuable content for learners like you. So hit subscribe now, and let's get started. Cloud computing is a way to deliver computing services over the internet without owning physical hardware. Think of it like electricity. You don't build a power plant, you simply plug in and use the energy. At its core, cloud computing provides flexibility, scalability, and access to resources when and where needed. It allows organizations to rent servers, storage, and applications instead of purchasing and maintaining them. This approach reduces upfront costs and shifts expenses into manageable monthly payments. Additionally, the cloud provides near-limitless capacity, enabling businesses to scale quickly during peak demand. It also improves collaboration, as teams across the globe can access the same tools and data. Cloud computing applies across industries, from streaming services to online education and healthcare systems. In short, it transforms IT into a utility service, offering agility, efficiency, and global reach for modern enterprises. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, and analytics, over the internet. Think of it like renting an apartment. You use the space, but you don't handle construction or repairs. The definition emphasizes the delivery of resources as a service rather than owning the underlying infrastructure. Key elements include on-demand availability, meaning resources can be used instantly when required. Another element is resource pooling, where multiple customers share scalable infrastructure while remaining isolated. Elasticity is critical, allowing organizations to scale resources up or down automatically with demand. Cloud computing reduces the need for heavy upfront investments, turning capital expenditure into operational costs. It applies in business continuity, application hosting, machine learning, and everyday collaboration tools. Simply put, cloud computing defines a modern IT model that's efficient, flexible, and accessible from virtually anywhere. The shared responsibility model defines who is accountable for security in cloud environments: cloud providers or customers. Picture it like renting a car. The company maintains the engine, but you're responsible for safe driving. In cloud computing, providers ensure the physical infrastructure, global availability, and foundational security of their services. Customers are responsible for securing data, configuring identities, and setting application-level protections. This balance means security is not entirely outsourced. It requires active participation from both sides. In IaaS, customers handle more controls, while in SaaS, providers assume most responsibility. The model reduces confusion, helping organizations understand exactly where their duties begin and end. It applies to governance, compliance, and technical security, from encrypting data to managing firewalls. Overall, the shared responsibility model ensures clarity, reducing risks and strengthening the security posture in cloud adoption. Cloud models describe how cloud services are deployed and managed: public, private, or hybrid. Think of them like housing options: apartments, single homes, or a mix of both. A public cloud is hosted by providers and shared across many customers with secure isolation. It offers cost efficiency, flexibility, and rapid scalability without infrastructure ownership. Private cloud serves a single organization, giving full control, customization, and strict data security. It is often used by industries needing compliance, such as banking or healthcare. Hybrid cloud combines both models, enabling businesses to keep sensitive data private while scaling workloads publicly. This approach maximizes flexibility, optimizing performance, security, and cost balance. In short, cloud models provide different paths to align technology choices with business strategy, compliance, and growth. Choosing the correct cloud model depends on business goals, data sensitivity, and operational needs. Think of it like choosing transportation: bicycle for short trips, car for flexibility, train for speed. Public cloud suits startups, seasonal workloads, and collaboration tools needing rapid scalability. It helps reduce costs by paying only for consumed resources. Private cloud fits organizations with strict regulatory requirements or sensitive workloads like financial records. It ensures data stays under exclusive organizational control with tailored security. Hybrid cloud supports industries needing both secure data storage combined with flexible web applications. It enables disaster recovery, burst workloads, and optimized resource distribution across environments. Overall, use cases highlight that no single model fits all, but each aligns with specific business needs. The consumption-based model means organizations pay only for the resources they actually use. It's like paying for water. The meter tracks consumption, and you're billed accordingly. This model eliminates the need for large upfront investments in hardware and software. It provides flexibility, allowing businesses to scale resources up or down on demand. Costs become operational expenses, making budgeting predictable and avoiding wasted infrastructure spending. It encourages efficiency since organizations monitor and optimize usage to reduce unnecessary costs. This model also democratizes IT, enabling startups to access enterprise-grade services affordably. It applies to virtual machines, storage, networking, and advanced analytics in the cloud. In summary, consumption-based pricing transforms IT spending into a utility approach, increasing agility and financial control. Cloud providers offer different pricing models to match workload patterns and budgets. Think of it like shopping. Pay-as-you-go is retail, reserved is bulk buying, and spot is discounts. Pay-as-you-go charges only for active usage, making it ideal for unpredictable or variable workloads. It provides flexibility, but may be more costly long-term if used continuously. Reserved pricing allows committing to resources for 1 or 3 years at reduced rates. It suits stable workloads where demand is predictable and consistent over time. Spot pricing offers deep discounts by using and used capacity. Those services can be interrupted. It is ideal for batch processing or non-critical tasks that tolerate interruptions. Together, these models empower organizations to balance cost, risk, and flexibility based on workload requirements. Serverless computing lets developers run code without managing servers or infrastructure. Think of it like ordering food delivery. You enjoy the meal without worrying about the kitchen. In serverless, the provider automatically handles scaling, patching, and resource management. Developers focus only on writing code that responds to events or triggers. Billing is based strictly on execution time and resources consumed during those executions. It eliminates idle costs, unlike traditional servers that run continuously even when in use. Serverless improves agility, allowing faster deployment of microservices and event-driven applications. It's applied in chatbots, IoT data processing, APIs, and background automation tasks. In short, serverless simplifies development, reduces operational burden, and allows innovation at a faster pace. Cloud services provide organizations with multiple advantages that reshape IT operations. Think of it like a subscription gym. You access equipment without owning or maintaining it. The first benefit is cost savings, since resources are paid only when used. Another is scalability, allowing quick adjustment to rising or falling demand levels. Global reach is also important, enabling businesses to deliver applications closer to users worldwide. Additionally, cloud services increase reliability through redundancy across multiple regions. Security is strengthened with built-in compliance, encryption, and monitoring features. Manageability improves since updates, maintenance, and scaling are handled seamlessly by providers. Altogether, cloud services deliver agility, innovation, and efficiency unmatched by traditional IT. High availability and scalability are core strengths of cloud computing. Think of them like highways. Multiple lanes reduce traffic jams and can expand when needed. High availability ensures applications remain accessible even during hardware or network failures. It's achieved through redundancy, fault tolerance, and global data centers. Scalability enables workloads to automatically adjust resources based on demand fluctuations. This prevents over-provisioning while ensuring smooth performance during peak usage. Together, these principles minimize downtime, improve user experience, and support business continuity. They apply to e-commerce sites, streaming platforms, and critical financial systems. In essence, high availability and scalability keep businesses resilient, responsive, and future-ready. Reliability and predictability ensure cloud resources behave consistently and meet expectations. Imagine a trusted airline. You rely on safe flights and predictable schedules every time. Reliability means workloads continue to function even if components fail, thanks to built-in redundancy. Predictability refers to consistent performance, cost structures, and service delivery over time. This reduces surprises and supports long-term planning for IT investments. Cloud providers guarantee reliability through service-level agreements, SLAs, and geographically distributed data centers. Predictable billing models help organizations plan budgets without sudden cost spikes. These benefits are crucial for healthcare, finance, and government sectors needing stability. In short, reliability and predictability build trust, ensuring the cloud delivers dependable results for businesses. Security and governance in the cloud help organizations safeguard data while meeting regulations. Think of it like a secure bank. You store valuables with protection and strict oversight. Cloud providers implement advanced security features, including encryption, firewalls, and continuous monitoring. They also maintain compliance certifications across industries like healthcare, finance, and government. Governance tools enforce policies, ensuring resources are used responsibly and within organizational guidelines. This reduces risks of misconfigurations, data leaks, and unauthorized access. Cloud platforms provide centralized dashboards, helping administrators track security posture and compliance status. These capabilities make it easier to align with legal requirements worldwide. Ultimately, security and governance benefits enable trust, resilience, and confidence in cloud adoption. Manageability in the cloud makes it easier to monitor, control, and optimize IT resources. Think of it like a smart home system. One app controls lights, security, and appliances. Cloud platforms provide centralized consoles where administrators manage networks, storage, and applications. Automation features handle scaling, patching, and updates without manual intervention. This reduces complexity, freeing IT teams to focus on innovation instead of maintenance. Manageability also includes visibility. Dashboards display usage, performance, and costs in real time. Policies and templates ensure consistent configurations across all resources. It applies in both small startups and large enterprises, keeping operations efficient. In summary, manageability brings order, clarity, and automation to cloud environments, enhancing productivity. IaaS provides virtualized computing resources over the internet, replacing physical hardware ownership. Think of it like renting an empty office. You furnish it to meet your business needs. With IaaS, providers supply servers, storage, and networking as on-demand resources. Customers manage operating systems, applications, and configurations on top of this foundation. It delivers flexibility to quickly spin up test environments or production systems. Costs are based on consumption, avoiding large upfront investments in hardware. IaaS is useful for migrations, disaster recovery, and dynamic workloads. It allows scaling infrastructure within minutes to meet changing demands. Overall, IaaS empowers organizations with control, scalability, and cost efficiency in infrastructure. PaaS provides a ready-to-use platform for developers to build, test, and deploy applications. Think of it like a furnished office. You bring your work, but don't manage the space. Providers handle infrastructure, operating systems, and runtime environments. Developers focus only on coding and delivering business solutions. PaaS accelerates application development by removing infrastructure management overhead. It also integrates tools for collaboration, testing, and version control. Billing is usage-based, making it cost-effective for agile teams and startups. Common use cases include web apps, APIs, and microservices deployment. In short, PaaS boosts innovation, enabling faster delivery of software with less complexity. SaaS delivers fully managed applications over the internet on a subscription basis. Think of it like streaming movies. You enjoy the service without managing servers or storage. The provider hosts the application, handles updates, and ensures high availability. Customers only need internet access to use the service. SaaS reduces the burden of installation, patching, and hardware compatibility. It also enables global collaboration, as users log in from anywhere on any device. Costs are predictable, typically charged monthly or annually per user. Examples include email services, productivity suites, and customer relationship management tools. In essence, SaaS democratizes access to enterprise-grade applications without operational overhead. IaaS is best suited for organizations needing full control of infrastructure without owning hardware. Think of it like leasing a warehouse. You control layout but don't own the building. One use case is disaster recovery, where organizations quickly replicate environments in the cloud. Another is testing and development, enabling teams to spin up servers on demand. It's also valuable for scaling seasonal workloads, such as e-commerce during holidays. IaaS supports legacy application migration by replicating existing on-premises environments. Businesses pay only for what they use, making it cost-efficient. Industries like finance and research rely on IaaS for high-performance computing. Overall, IaaS use cases emphasize flexibility, scalability, and efficiency. PaaS use cases revolve around rapid application development without infrastructure concerns. Think of it like a co-working space. The setup is ready, you focus on work. One scenario is building web and mobile applications with pre-built frameworks. Another is hosting APIs, simplifying integration across multiple systems. PaaS also supports microservices architecture, allowing modular, scalable app deployment. It integrates with DevOps pipelines, enabling continuous testing and delivery. Startups use PaaS for speed to market, while enterprises leverage it for agility. It reduces time spent managing databases, operating systems, or runtime environments. Overall, PaaS fits cases where faster innovation and collaboration are priorities. SaaS is ideal when organizations want instant access to fully managed applications. Think of it like renting a car service. You ride without worrying about fuel or repairs. A primary use case is email and collaboration tools, such as business productivity suites. Another is customer relationship management platforms, boosting sales and support efficiency. SaaS also powers e-learning systems, enabling remote training and education globally. It suits small businesses lacking IT staff, as everything is managed by providers. Enterprises use SaaS for HR, finance, and supply chain management applications. Its subscription model makes costs predictable and scalable by user count. In short, SaaS is perfect where simplicity, accessibility, and collaboration are key.